Hey Chem Kids, Campbell here. In our second video on stoichiometry, we're going to talk about mass-to-mass problems. So remember that stoichiometry is a way for us to use our mole ratio, the heart of every stoichiometry problem, to convert from one substance to another substance. And in our last video, we did the middle, the mole to mole. We did mass to mole or mole to mass. But today, we're going to do mass to mass calculations. In another video, we'll do mass to volume and volume to volume. So in a mass to mass, what we're doing is we're converting mass or grams of something we're given in the problem, it's the thing we have the number for in the problem statement, to moles. And then we're going to use that mole ratio, the heart of our stoichiometry problem, to go to moles of what we're trying to find. And then finally, we're going to go from those moles to the mass. So step one, because that heart of the stoichiometry problem is the mole ratio from our balanced chemical equation, the first thing we need to do is balance our chemical equation. The second thing we're going to do is we're going to go through and write down what we have and identify what we're trying to find. Now, I will actually start off by doing that in the problem statement before I actually start writing it down. Step three, we're going to convert from grams of what we were given to moles of what we were given by dividing by molar mass, right? To go from grams to moles, we divide by molar mass. So we have to go to the periodic table, look up all the elements, add them all together, and then divide. Once we get moles of that, we go to multiplying by our mole ratio. And in our mole ratio, that comes from a balanced chemical reaction equation. And the number on top is the number in front of that chemical formula of what we're trying to find. The number on the bottom is the number in front of what we were given. So we're going to multiply by that ratio, and that's going to put us in moles of what we're trying to find. So then the last thing we're going to do is then, we don't want moles, we want to go to mass. So we're going to multiply, right? Anytime you have moles, you multiply by the molar mass of the thing we're trying to find. Don't use the molar mass that you calculated before. You got to calculate another one. So let's do this. So I want to know how many grams of sodium nitrate are produced, sorry, that should be a D, if 50 grams of sodium carbonate is reacted with nitric acid. All right, well, remember the first thing I want to do is balance my chemical reaction. So if I look here, I have 2 sodiums, so I'm going to put a 2 here because right now I only have 1, so that gives me 2. Now when I do that, that means I have 2 nitrates. And notice that nitrates are here. Even though I have oxygens on both sides, I don't see nitrogen anywhere else. So I'm going to treat this as 2 nitrates. And this is 1 nitrate, which means I'm going to have to put a 2 there. Putting a 2 there means I have 2 hydrogens, but that's cool because I have 2 hydrogens here. Now let's go back over here. We didn't look at carbons yet. I have 1 carbon here and 1 carbon here, so that's good. And I have 3 oxygens not in nitrate here. But that's okay because I have 2 plus 1, 3 oxygens there. So we're balanced. Step 1, check. Step 2, find what we're trying to find. So we have 50 grams, right? Find the number and what it's attached to. So I'm going to write that down, 50 grams of sodium carbonate. So that's this stuff right here. I have 50 grams of that stuff. Now this is blah, 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 blah. Don't care about that. What I want to find is how many grams of sodium nitrate are produced. So I want to know grams of this thing. That's sodium nitrate. Okay. So I wrote down what I was given. And so now I'm going to divide by the molar mass of sodium carbonate. So remember, to calculate molar mass, you have to go to the periodic table and look up all of the elements we have in sodium carbonate. So I have sodium, and on the periodic table, sodium is 23. Now, there are 2 of them, right? So don't forget to multiply by 2. So that's 46. Carbon on the periodic table is 12. There's only 1 carbon here, so we'll just write times 1. We don't really need to do that. Oxygen on the periodic table is 16, and there's 3 of them, so that's 48. So this total here, if we do some quick math, is 106. So I'm going to take 50 grams, and I'm going to divide by 106. Moles, that's grams per mole, grams per mole. And that is going to give me 0.47 moles, sorry about that, moles of sodium carbonate. Okay, so now I got moles. So now we're going to use the heart of the stoichiometry problem, our mole ratio. Okay, so we have 0.47 moles of Na2CO3. And so we're going to multiply by our mole ratio. On the top of the ratio is the number in front of what we're trying to find. This is the thing we're trying to find. The number in front is 2. So that means I have 2 moles of NaNO3. The number on the bottom is the number in front of what we were given. We were given sodium carbonate. Notice there's no number there. That means that's 1. So Na2CO3. All right, so I'm going to take 0.47 and I'm going to multiply by 2 because this is the heart of my stoichiometry problem. And that's going to give me 0.94. But now I'm not in moles of sodium carbonate. I'm in moles of sodium nitrate, NaNO3. So now I got one more step to go, right? That's exactly what we did in the last video. What we got to do now, though, is one last step. We're going to take that's supposed to be a 9.94 moles of sodium nitrate. And we are going to, when you have moles, you multiply by the molar mass of sodium nitrate. So let's look up sodium nitrate, nitrogen, and oxygen. Sodium, again, is 23. This time I only have one of them, so that's just 23. Nitrogen, there's only one. Nitrogen on the periodic table is 14. So 14. Oxygen on the periodic table is 16. I have 3 of these, which I had last time. So that's 48. So my total molar mass for this is 85. Nope. 85, 8, 9, 10, 11, 12, 13, 14, 15. Yeah, 85. I can do math. Not very well sometimes. All right, so we're going to multiply this by 85 grams per mole of sodium nitrate. And we're going to get our final answer of 79.9, sorry, go away, 9 grams of sodium nitrate. All right, that's our final answer. So balance your reaction, write down what you have, convert it to moles by dividing by molar mass, multiply by your mole ratio, then multiply by the molar mass of what you're trying to find. Let's do one more. Let's see if you can do this. Why don't you pause the video, see if you can work through this problem, see how far you get, and then unpause and see if you did it right. Well, first we got to balance. I have 1 calcium, 1 calcium. Calcium's cool, but I have 2 nitrates here and I only have 1 here, so we're going to put a 2 there. I have 2 potassiums, 2 potassiums. That is cool. I have 1 CO3, 1 CO3, so carbonates, check. All right, well that was pretty easy. So the number I'm given is 100 grams of this stuff and blah, 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 blah. Don't care about that. I want to know how many grams of potassium nitrate, so this stuff I've formed. Now notice it's kind of the same pattern from an equation standpoint as the last slide, but that's not always the case. So always try to figure out what it is that you're given and write it down. So I'm given 100 grams, that's my number, of calcium nitrate. And so first thing we got to do now is divide by the molar mass of calcium nitrate. So we got to go to the periodic table. Calcium is 40 on the periodic table. There's only 1 calcium here. The 2 goes to the parentheses inside. We have nitrogen, which is 14 on the periodic table. We have to distribute this 2. So the 2 goes to the nitrogen as well. So that's 28. And then for oxygen, we got a lot because we got 3 times 2 is 6. So oxygen on the periodic table is 16 times 6 is 96. So that means this is 164 grams per mole of calcium nitrate. So we're going to divide by 164. When we do that, we're going to get 0.61 moles, now we're in moles, of calcium nitrate. Next step is to do our mole conversion. So our heart of our stoichiometry problem. So 0.61 moles of calcium nitrate. I always like to write it down so we don't forget what we have. And we're going to do our little heart. On the top of the heart is a number in front of what we're trying to find. So once again, that's a 2. That's just a coincidence there. And down on the bottom is the number in front of what we were given. We were given calcium nitrate, so that's going to be a 1. So just like the last problem, and like I said, that's a coincidence, right? That's supposed to be an equal sign. We're going to take 0.61 and we're going to multiply by 2, and that's going to give us 1.22, and this is now moles of our potassium nitrate, that thing we're trying to find. Remember, that's what this mole ratio does. It converts us from one substance to another. Now our last step is to multiply our moles of potassium nitrate by the molar mass of potassium nitrate. So you have to calculate this. You can't just use the one you had before. So potassium on the periodic table is 39. And there's only one of them. Nitrogen, again, we have lots of nitrogen today, is 14. There's only one, so that's 14. And oxygen, it's a popular 16. Oops. There's 3 of them. We've done a lot of that today. 16 times 3 is 48. Add that all up, and that's 101 grams. All right, so we're going to take 1.22 and we're going to multiply by 101 grams per mole, and that gives us 123.2 grams of potassium nitrate. Did you get that? Did you do it? Well, we're going to do more practice in class, so I will see you in class.